Hi there, my name is Everett Toews. I'd like to walk you through the ideas and concepts for doing GitOps driven deployments on OpenShift. Okay, so a quick intro for myself. Again, my name is Everett Toews. Last name looks nothing like it sounds. That's okay. I'm eTaves on GitHub, Twitter, LinkedIn, and my blog where you can find this presentation. I'm a platform engineer at Deloitte Digital, and I'm actually residing in New Zealand at the moment, but I'm from Canada. Okay, so what is GitOps? Very broadly speaking, it's applying the Git workflow to operations. And as a developer and an ops person, I put more and more and more stuff in Git as my career has progressed. So this notion of applying the Git workflow to operation is really natural to me and really appeals to me. But said slightly differently, you could say that we're applying a developer experience to operations. Because a developer experience is more than just APIs and documentation and tutorials and all those things. It's interacting with Git. It's the kind of things we do every single day, day in, day out. And so to apply that to operations seems like a very natural fit. Let's start at the end. This is how the GitOps driven deployments flow actually works on OpenShift. So a new version for a service of an application is proposed via pull request, a PR. When that pull request is merged, a webhook fires and the new version rolls out. And that's it. So here's what it actually looks like in action. And a lot of this isn't going to make sense, right from the get-go. But I wanted to give you an idea of how it all fits together, end to end, before I actually kind of explain it all. And I'll go into quite a bit of detail for all of these things. So here, just showing off some of the pipelines on OpenShift that actually drive the deployments. That's what we're looking at here. Here's some of the Git repos that actually represent the environments that we deploy to. And in those repos, there's really just a couple of files. And so if we want to actually create a new version, roll out a new version of one of the services, we create a pull request for it. And, normally you would get an approval for your pull request, but in this case, I'm just trying to roll something out for a demo, and I just fire it off. And that goes ahead and kicks off a pipeline run. And so it begins with the first application, the first service in our stack, this thing known as the identity server. And it goes ahead and does a handful of steps that I'll get into a little more later, and rolls out that service, and then goes ahead and starts rolling out the next service. And all of this goes very quickly because there's some optimizations within the pipelines, and we're actually deploying something that's already been deployed. So all of these things happen really very quickly. If an actual build needs to occur, these things would take kind of significantly longer, on the order of a minute or two. Or in the case of the UI, the build actually can take up to 5 or even 10 minutes in some cases. So now we're going through this same set of steps for the UI. There's a linting step in there that takes a little bit longer, and so I just did a quick time lapse, and then it goes ahead and goes through the rest of the steps, very similar to the other pipelines. And so once that has rolled out and been verified, we're done. We've rolled out a new version of one or more of the services in our application stack. And here they are, running with, they're running pods in the environment. Let's zoom out a bit. Here's the stack I've been referring to the whole time. Actually, out at the edge, There's an API gateway on Azure. That UI component, known as the EdPay UI, that's actually running or is being served from on-prem, which is on OpenShift, on-premise within one of our data centers. The API, likewise, also running on-prem on OpenShift, and the identity server providing the authentication for these components, again, on-prem and on OpenShift. And then underlying all of those components, all of those services is a monolithic DB, also on-prem, but not on OpenShift in this case. So here's kind of a very basic architecture diagram. The user interface, the UI, is a single page application written in Node, TypeScript to be exact, and it gets downloaded from the web server that's running on OpenShift, and then it starts making calls to the API through the Azure gateway. And of course, before you do anything, you need to authenticate via the identity server. And the API and identity server are backed by the monolithic database. Okay, so in terms of the deployments on OpenShift, what's the flow? How does GitOps kind of work with this sort of deployment model? Okay, so obviously you always start with your users, and in this case, it's the environment owners, your dev, your test, your pre-production, your production environments. That's what I mean when I say environments. The owners of these things, they're really the users of this particular aspect of the system. Of course, there's Git. They're making their pull requests in Git. Then there's the pipelines that we saw get kicked off in the video. And then there's the environments, which are in fact just OpenShift projects, running within OpenShift and being used to isolate the various environments from each other. Here's a great big wide view of the pipeline that we actually saw running in the video, and it's far too much to just explain in one go. So let's bite it off bit by bit. The first part is Git, and I'm just going to go ahead and assume that you know what Git is if you're watching this presentation. Okay, so up and to the left here is kind of where all of the various stages they're constantly interacting with Git, but kind of the important bit for the purposes of this of driving these deployments is reading in the configuration of an environment from Git. And that's kind of one of the very first steps after a user, one of the environment owners has actually merged a commit, or you can manually start the pipeline as well. So what does Git do for us? It provides great access control and audit, all of those things that we're probably pretty used to using, practically any Git product out there. And in our case, it happens to be Bitbucket, but all of them do more or less the same thing. And then there's, the repo permissions, branch permissions, pull request and reviewers, configuration around those, and webhooks. And all of these things are configured for the environment repos, which I'll explain in a moment. And then we have Git tags on the service repos, which I'll get to afterwards. So what are these environment repos? These are the quite small repositories that are the home of the configuration that defines an environment. So again, these are your software development lifecycle environments, your dev, your test, your pre-prod. We have one for demos. We've got kind of a lab environment, and of course, production as well. And these Env repos are just really made up of a couple simple files. There's the service.properties, which contains kind of all of the configuration that the services connect to. That really, so the primary example is what database does this environment connect to, and that really kind of defines the environment is what database it connects to. And then the version properties just define all of the different versions of the various services within that environment. So there's a version for the UI, there's a version for the API, and there's a version for the identity server. The repo permissions, it really pays to, of course, define your user access. You give admin to your environment owners, right to those who can update the environment. So let's say a tester wants to propose a new version of the API in a particular environment. They'll go ahead and do a pull request for it, and the environment owner will accept it or reject it. And then, of course, group access if you want people to read the configuration for your environment. Branch permissions, it's a good idea to set these. You don't want to have people deleting your master branch or rewriting history, and certainly not making changes without a pull request. And then when it comes to PRs and default reviewers, you want to make sure you have some settings for pull requests where you require a certain number of approvers, and then you have your default reviewers for the master branch. And these are the people who get an email when somebody is proposing a new version to an environment. So, that's part of the flow as well, is that the owners of the environment, there can be more than one. The owners of the environment get an email, and one of them will go ahead and approve it and actually merge it. And that's defined by the default reviewers. And, you want to set it greater than one. So the webhooks, these are really just a URL that you set within the repo, within the environment repo. And you want to set it, we'll take a look at where the URL for the webhook actually comes from. Of course, it wants to be active, and then you define what pull request event cause it to fire. And in our case, it's only when a pull request is actually merged. So here in OpenShift, we take the webhook for an environment pipeline, and we copy that and we paste it into the environment repo settings. There's a configuration screen where you can go and just paste it in there along with all the other configuration for the environment that I was specifying there. So that was the environment repos. We also have the service repos, and these are the repos that just have your regular application source code. This is the source code that makes up the running services in your environments. And in this case, there's the in this particular Bitbucket project, there's EdPay services and the identity server. The UI actually just lives in a different project, and that's why we don't see it here. And, like I mentioned, it's just your basic everyday source code repo. In this particular case, it's a C# application. All of this is being written in .NET. And so it's just a matter of, drilling down into the source code to see where everything is. Now, as part of these service repos, the way we define the versions for them are actually tagging commits on the master branch. That is what it defines a version, and that's the thing that actually gets built from that commit. So we have immutable images, but we're also able to rebuild anything, because that particular commit has been tagged with a particular version number in Git, and we can always rebuild that thing by specifying that version in the version.properties file for an environment. So the next part of the flow is the pipelines themselves. Now, I like to consider the pipelines as the interface to the OpenShift container platform. And, they in one end, they take source code and configuration, and out the other end, they spit out container images and deployments. And for kind of your day-to-day work with the platform, it's effectively your interface. And it's represented by this GitOps flow that I've defined here. So, much like the repos, we have environment repos and service repos. We also have environment pipelines and service pipelines. Starting with the environment pipelines. If you recall from the video there, we had the deploy devo3 master pipeline. There's just a simple naming convention that you deploy to the environment name. And these are made up of all the individual Git repos we saw earlier. And it just contains that service.properties and version.properties. That's our configuration and versions. And this pipeline actually invokes the service pipelines as kind of sub pipelines. And after it's run those service pipelines and they've done their deployments, it goes ahead and it verifies the deployments. So this is kind of the pipeline that runs the other pipelines effectively and checks up on them. And it's represented here over on the left in terms of the sequence. So then there are the service pipelines, and they're responsible for building and deploying the individual services. And they just have a simple naming convention: deploy -service name, so deploy edpay UI, deploy edpay services, deploy identity server. And they're just the individual Git repos with all of your source code, and they invoke builds and deployments. So they'll actually run a build and create a container image. And kind of one of the key bits of this is the usage of OpenShift templates. So when we actually go to do that deployment of a service, the version of the service is templated out. And so it's a matter of having to process a template and insert that version, which comes from the version.properties file in Bitbucket in Git. And then we go ahead and we apply that. So even if that version number has stayed the same, from deployment to deployment, we still run this bit of code and we let OpenShift work out that it doesn't actually need to do anything because the same application version is being applied. And that's just, default out of the box behavior for Kubernetes and OpenShift. And so here are those three different services that we're actually building and deploying as part of this stack that are invoked from the environment pipeline. And they're represented over here successively to the right. Okay, so touching on builds, of course, we have to build our immutable container images, similar kind of naming scheme. And we're actually using the source to image feature in OpenShift, for the .NET S2I image builder. We don't even have Docker files at this point. We just point OpenShift at the repos and it takes care of the rest. And so this is just an example of the builds that we have, in the Devo3 master environment. Okay, so these environments that I keep going on about, they're really just a combination of the running services, the pods, and some configuration in an OpenShift project. And if you go to the overview tab in the OpenShift UI, you get a nice view of all your running services and the various amount of pods they're actually made up of. Of course, the configuration is defined by config maps, and in this case, we just have one config map, some JSON config that actually configures the various services, and naturally we have secrets as well that are injected into the deployments, into the deployment configs, and of course we're not going to show those, but yeah, we keep everything in secrets as well. So then there's the kind of the lower environments, where the builds actually happen. and where much of the development goes on. These follow another naming convention. Again, it's all very database centric. That's really the core thing that defines the environments at this place. And then the version that we're actually building and deploying. So it's these environments do both things. And in this particular case, what does master mean? So this actually means that when you run the pipeline for this environment, that it'll build off the head commit of the master branch for each service. So this is like the latest, the absolute latest and greatest of each and every service. You know, it could be broken, might not work at all, but it's just an early place to integrate everything and see if it's, you know, even remotely working together at all. And maybe master is a bit of a misnomer in terms of, you know, version, and you could have easily have been called head, but I just went with master, and that's what stuck. Then there's also a Devo3 stable environment, and this is the first place where the services actually get versioned, and versioned container images get built based on those tags in Git for the various services. And that is the full end-to-end pipeline run for actually driving a deployment out on OpenShift. So, and you know, that was particular to the build and dev environments, but there are also the higher environments. In fact, they make up the majority of the environments, but they're distinct from the build and dev environments because these environments, again, just named after the databases, these environments only do deployments. And so they don't actually do the build components because, you know, we want to reuse those immutable container images that we've built once. There's just no need to rebuild them, and it's in fact much better to just reuse them. And really, prod is just another higher environment, the same as, you know, any of the other higher environments like demo or any of the test environments or pre-prod. The only difference in our case is that the prod environment is an OpenShift project on a different cluster. So we actually have a couple data centers, and we have a non-prod cluster and a prod cluster. And in order to deploy to prod, we have to copy the image that we want to deploy over to prod first, and then everything else is exactly the same as the other higher environment pipelines. And of course, really the key difference for prod is that it has much greater restricted access in terms of who can even touch the environment whatsoever or touch the cluster. And this is what a pipeline for a higher environment looks like. Much simpler than the pipeline for the build or dev environments. And that kind of brings us back to the end. You know, I've explained all the concepts behind this, and just to remind you of kind of what that higher level flow is that brings it all together. User proposes a new version via pull request. When that PR is merged by an environment owner, a webhook fires, and a new version gets rolled out. So let's review the video again and see if we can make more sense of this Devo3 master pipeline run. So we'll jump into the pipelines first thing. So nothing's running right now. That's just a previous run. Here's the various service pipelines. And now we're going to switch over to our environment repos. And just take a quick look inside Devo3 master. There's the service.properties that contains our config, and version.properties that contains our versions. Got a pull request already in flight here. And it's really just to kind of test out the webhook. So it's doing a kind of a very minor change, just to trigger the webhook. We're not actually going to wind up rebuilding any of the images, so everything will go really very quickly when it comes to the pipeline. And so the environment pipeline, the webhook fired, and that's what kicked off this environment pipeline. So it in turn goes ahead and kicks off the other service pipelines, starting with the identity server. And it goes ahead and it does its thing, running the various steps. The environment pipeline verifies it. Then we kick off the API services pipeline. And it gets its configuration, and it doesn't actually have to build and tag anything because it was already built. There's some optimizations in here. Quick verification of that step. And then we run the pipeline for the UI, the next service in the stack. And again, this service pipeline has some optimizations in it. There is a linting step here. So there's a time lapse, just so we don't have to wait around for it. And then it goes ahead and gets the config for this service in this environment. There's nothing to build and tag because it's already built. That means it's already deployed from a previous pipeline run. And of course, the verification happens very quickly too. And our pipeline run is successful. And all of our services are up and running in our Devo3 master environment. So some notes on this whole thing. This really represents like a full year of work, honestly, with this great client here in Wellington, New Zealand. But of course, like any good system or project, there's a handful of things I would have done differently, and so here are notes on that. We kind of never got around to having a good story for local OpenShift development environments, meaning they don't have like Minishift or something like that running on their desktops or their laptops, the actual developers of these services. So there's no kind of good higher fidelity environment for them to develop in before they actually push stuff out, to the repos and onto the clusters running in the data centers. They just kind of do their development locally as you normally would on any desktop, and then commit from there. But honestly, for the most part, it works reasonably well. So like it all looks and seems and sounds relatively simple, and it is. But to get it to a point of being able to maintain that many environments, the OpenShift projects within the clusters, because there's quite a few environments there, over a dozen. To make that maintainable, we had to inline a lot of Jenkins files and do some other kind of somewhat tricky things that aren't maybe immediately obvious when you're first reviewing the stuff. So we incurred a fair amount of complexity to make it maintainable in that sense, which was a trade-off we were eventually comfortable with, because otherwise it just wouldn't have been particularly maintainable, that number of environments. The system by its nature does not deal with divergence. You have to like if you go in and tweak some setting in an environment, you kind of got to remember to make a note to undo that tweak. Once you've got it into source code, or you've just decided not to do that. Maybe you're trying something out, testing something out, and it didn't work out. You got to remember to kind of back that change out manually. One thing that the pipelines don't have is like a facility to automatically roll back. It's more of you would just submit another pull request and roll back that way if something were to fail or things were going wrong in a particular pipeline run. And for the most part, that's really okay. That's actually a trade-off that's worked out reasonably well. We haven't really had a lot of times when we really wished we had automatic rollback, and if a pipeline does fail, it really honestly usually requires human intervention anyway. and versioning, like one of my favorite topics. Version all the things, like, of course we version the container images and that stuff. And then just as we started getting deeper and deeper into things, just like we versioned absolutely everything. The deployment configs lived alongside the service code, the source code of the services. The config maps were versioned. They're effectively an interface, a dependency of a particular version of an application. The environments themselves were versioned. And so we actually roll out versions of the different environments, because we're constantly tweaking the environments as well to support the application. Effectively, the environment is just another application dependency, so we version it and treat it as such. And what else would I do differently here? This winds up being a fairly open system. You can do a lot with it, and kind of decide how you want to interact with it. And it's quite open, which I think can actually be kind of intimidating. Because when I first presented the system to the client, it wasn't entirely obvious how they wanted to use it. I knew that they would eventually get it, and find a way that they were comfortable of working with it. That was kind of what I always intended. But I think I could have been more prescriptive about it, and maybe presented a way of saying, okay, so here's this open-ended system, and here is one really good way to use it. But eventually we got there anyway. So I had those build/dev environments. I probably would have just had a project dedicated just to builds, just a place a project just to house the image builds and do builds only, and not builds and deployments for the development environments. As it stands right now, this system is kind of very much geared to deploying this one application stack on these relatively small OpenShift clusters, to be honest. And so to actually scale this thing, especially in terms of the GitOps and all that, and adding different application stacks and more environments and stuff, I think would require a bit more work. But I think all the fundamental pieces are there anyway. So as I've been working on this thing, I've also come across some things that are related as well. Jenkins X being by far the the most similar thing. Jenkins X was a thing when I first started doing this, but it wasn't very far along at all. And honestly, I hadn't even really looked at it. But now that I've looked at it a bit, it's actually there are a number of similarities between Jenkins X and what I've done here. So I think Jenkins X warrants a much closer look. Weaveworks was they kind of in some sense coined the term GitOps, or certainly popularized it with a blog post or two, really not that long ago, just 2 or 3 years back. I've come across some other blog posts. This one in particular from Container Solutions. The people there had a really good take on the stuff. And then this was a research paper around GitOps, and a path to more self-service IT, which, while not directly related to deploying applications and services, I thought was a really great take on using GitOps to enable companies to just create self-service IT in general. And okay, that now brings us to the end, for real this time. Thank you so much for your time and attention here. Cheers.